This is 8th grade math. We are in your packet. This should follow perfectly. So we're going to start with the back of the first page where it says problem 1.2. Now, you have an A, a B, a C, and a D. So this is A. And this, I just have a map under each. If you look at the next page, you have two maps, and you're going to put all of this in those two maps. So, letter A says, suppose you have a park, and it's going to be a square. So this is the map of your park. If I go back to the first page, actually, there's a little story. So the Euclid City Council is developing parks with geometric shapes. You can read that. Gotcha. So vertices are the corners. So 1, 1 and 4, 2 are actually already plotted for you. And they're plotted on your map also. So locate those. And the question is, you want a square. So in a minute, hit pause in a minute, and go ahead and see if you can figure out how to make a square, you know what I'm saying, of some sort, a perfect square, with the two dots, the two ordered pairs that are listed as corners. So a perfect square with the two dots as corners. So go ahead and pause right now and see if you can do that. Just give yourself a minute to think. Okay, so if something is square, that means it has to have the same side length and 90-degree angles. So if you look at this, this is like an up 1 over 2, and this is also a 2 by 1. And if you connect those, this is a 90-degree angle. Those are perpendicular lines. You're going to learn in a little bit that perpendicular lines have opposite reciprocal slopes. We haven't got into slopes too much yet, so just take that and just do nothing with it. Okay, perfect. So then the other one right here would be over 2 up 1 and over 2 up 1. So that is a lovely square. That's only one option. There are more. So tomorrow, if you found a different one, I want you to bring that to class, and we are going to discuss that. If you have the one, you're good for now. All right, next up. This says a non-square rectangle. So that is a parallelogram. So that means the corners are not 90 degrees. So if you're thinking of this, that is a normal rectangle with 90-degree corners. So that is not what we're thinking. All you need to do is sort of like shift these lines over, and then you would shift like this. So that would be a parallelogram. So opposite sides parallel, and this is not 90-degree angles. Again, there are multiple right answers for this. The thing is, it just asks that these are vertices, which means these are 2 of the 4 corners. So you could find tons. You could move this farther out and make it look like this. So go ahead and see if you can find another one right now. Okay, so a right triangle. A right triangle is half of a rectangle. It has a 90-degree angle. So we have one possible right triangle right there. You have another possible right triangle right there. Remember that square we made? So I guess that actually wouldn't work. I was thinking half of a square is a right triangle. Yeah, it does right there. It's just that the hypotenuse, the diagonal, is across from the 90-degree angle. And then there's actually one more. So that's the half of the square. So there are 4 possible right triangles that you can create. Wait a second here. Okay, so for B, I actually just did D. So B is even easier. It's just the basic rectangle, like so. So make B say that. D is now done. And now we're going to flip the page. So the next section here is talking about areas. If you remember, the basic square, this little square right here, is a 1 by 1, which is 1. So if you break this up into squares, this area is 2 units squared. Now, last year you did this and you approximated. There's no approximating here. Tomorrow I'm going to give you another sheet and we're going to find more areas, so I just want you to have this base foundation. So you need to break these shapes up into perfect rectangles and perfect triangles that you can find areas of. So that square area is 1. Now, if you look at this triangle, area of a triangle is base times height divided by 2. So base times height divided by 2 is 1 times 1 divided by 2, which is 1/2. Another way to think about this is you know that this square's area is 1, and you've cut it in half. So this answer is 1.5 units squared. So you have 2 options when you're finding area. One is to draw a box around and to subtract the excess. So if you're looking at this lovely red box, it's a 2 by 2, which is 4. And then each of these triangles is a 2 by 1. So this triangle's area is 1. And this triangle's area is also 1. So if you subtract both of those 1s, you get an answer of 2 units squared. The other way is to just break the triangle up. This triangle has a height of 2 and a base of 2. You can think of it as 2 separate triangles, or you can think of it as one big triangle. So regardless, the area is 2. This would be 1 and this would be 1, or you have a 2 by 2, which is 4, divided by 2, which is 2. So the area is 2 units squared. Alright, let's break this up like so. Each of the perfect squares are 1. Each of the triangles are 1/2. So that is 1, 2, 3, 4 units squared. Alright, take a minute, pause me, and see if you can get these areas, and then play and see if you're right. So you are paused. So in 5, you need to break this up into triangles, right triangles, with perfect bases and perfect heights. So this triangle right here is a 1 by 1, so that's 1/2. And when I'm talking about a 1 by 1, I'm talking about the space between the dots. And then the other 2 triangles are both 2 by 1s. So those areas are 1, because 2 times 1 divided by 2, base times height divided by 2 is 1. So the answer for this is 3 units squared. Okay, so squares I know, triangles I know. These are 1, these are 1/2, and this is 1 because we just did that. So 1, 2, 3, 4 units squared. I know this triangle is 1 because it's a 2 by 1. This triangle is a 1/2. This triangle is another 2 by 1, so that's 1, and that's 1. So that's 3.5 units squared. Okay. That's a 2 by 1. So that's 1. This is another 2 by 1. So that's 1. This is 1/2. Now, this is a 2 by 2. You could break this into 2 boxes, or you could just put 2. This triangle is a 2 by 1, so that's 1. This triangle is a 2 by 1, so that's 1. So we have 1, 2, 3, 4, 5, 6.5 units squared. Okay, this one's looking a wee bit more weird. So this is 1/2. We can totally conquer it though. This is 3 boxes right here. So I'm just going to make it large and put 3. This triangle is a 2 by 1, so that's 1. This is a 1/2. Here is a box right here. That's 1. This is a 1/2. Now, the triangle above, up top right here, you could actually, this is 2. You have to drop the height on the outside. So the base is 2 and the height is 1. So this triangle is also 1. You could shift this triangle to make it be a 2 by 1 normal, and that's the exact same area as this thing shifted this way. You could also make it like a 2 by 1 way over here. So any 2 by 1 triangle with a base of 2 and a height of 1, no matter how far over it's shifted, has an area of 1. So when you're finding height, you have to drop the altitude, the height, to hit where the base would have been at a 90-degree angle. So we're going to practice that again right here. This is a 2. This height is right here. The height is 1. So this 2 by 1 triangle has an area of 1. If that is not jiving with you, let's draw a box around this. So in the box around this, we have a 3, 1, 2, 3 by 1. So a 3 by 1, the whole box is an area of 3. And then you would need to subtract the excess. So this is a 1/2. And then this triangle is a 3 by 1. So a 3 by 1 is 1.5. So 1.5 plus 1/2 is 2. So do you see how you're left with 1 again? So the total area for number 9 is 1, 2, 3, 4, 5, 6, 7, 8.5 units squared, because area is always units squared. The grand finale. So this parallelogram you can cut into 2 triangles. This is 3. This is 2. And then this triangle is a 2 by 1, so that's 1. And this one is a 3 by 1, so that's 1.5. So you are adding them up. 1, 2, 3, 4, 5, 6, 7, 8.5 units squared. Alright, so you should be able to draw shapes, and you should be able to read to say if it says rectangle or parallelogram, and you should be able to find areas of shapes that you can break up. We will continue this tomorrow and then move forward. Have a lovely evening.